In the time of dinosaurs, Earth looked very different, with various landmasses dotting its surface throughout history. These landmasses ranged from small microcontinents to massive pieces of land known as supercontinents, with Pangea, Gondwana, and Pannotia being the most recent. They would eventually break apart into smaller continents separated by vast oceans, much like how Earth is today. But what if, during this process, one of the landmasses that separated just went missing? That is what happened to Argoland. Join us as we explore the mysterious disappearance of Argoland and where this continent is located today. What is Argoland? Around 155 million years ago, during the late Jurassic era, scientists proposed that a massive 5,000-kilometer chunk of continent named Argoland separated from northwestern Australia and drifted away. But how could scientists know about the existence of a continent hundreds of millions of years ago? Something as significant as a continent splitting up will leave lasting evidence for us to find. This hypothesis is based on the noticeable void it left. This void is the basin known as the Argo-Abyssal Plain, lying deep beneath the ocean off northwestern Australia's coast. The term abyssal plain refers to a flat region on the ocean floor, typically at the base of a continental rise, with a slope ratio of less than 1 to 1,000. The seafloor structure in this area strongly suggests that Argoland, as proposed by scientists, drifted northwest, ultimately arriving where the islands of Southeast Asia now exist. But things are not that simple. Scientists have been struggling to completely validate their hypotheses. And that's because we've never experienced anything like this with other continents before. The mysterious disappearance. Scientists knew that Argoland drifted away to the north of Australia, so it had to be somewhere beneath the islands of Southeast Asia. But when they went there to look for proof, they found something else. They found no proof of a large hidden continent beneath the islands of Southeast Asia. Instead, they found small continental fragments which confused them. But this led them to postulate another hypothesis. Maybe Argoland split up into different parts and then ended up in different parts of Southeast Asia. The case of Argoland is very different from what we know. Take India for instance. India diverged from the ancient supercontinent Gondwana 120 million years ago. But it's still a cohesive landmass today. On the other hand, Argoland disintegrated into fragments, which confuse scientists. This makes it very difficult for them to properly trace the locations of modern-day Argoland and figure out where the fragments are today. Lead researcher GreaterAdria and his colleagues from Utrecht University in the Netherlands detailed their findings in a study published online on October 19, 2023 in Gondwana Research. Seeking to reconstruct the journey of the detached continent, they identified fragments of ancient land scattered across Indonesia and Myanmar. So the next step would be to piece these fragments together and find the shape of Argoland. However, assembling Argoland from these pieces proved futile. They tried to piece these together, but they didn't fit. So the team decided to do something different. Instead of trying to trace the continent's path all the way from Australia to Southeast Asia chronologically, they'll start from Southeast Asia and then work their way backward in reverse. The team collected evidence in Southeast Asia to retrace Argoland's northward trajectory. Amid these fragments, remnants of small oceans dating back roughly 200 million years were discovered. These oceans likely formed as tectonic forces stretched and fractured Argoland before the landmass separated. The prolonged process spanned 50 to 60 million years. Then, after this process, about 155 million years ago, this amalgamation of ribbon continents and intervening oceans commenced its drift towards Southeast Asia. The lead researcher advocate states that we didn't lose a continent. Argoland was fragmented and separated from the start. Argoland was never a cohesive continent in the first place. It was always scattered and separated by the ocean. That's why the pieces never combined to form a single landmass. Advocate calls this an archipelago. This reimagining of Argoland's history may offer insights into the region's past climate, suggesting cooling as oceans formed among the remnants of Argoland. But there's also a pressing question that needs to be addressed. How can something as big as a continent simply vanish? How can a continent vanish? Earth's crust is divided by geologists into two main types: the denser oceanic crust and the lighter continental crust. The latter can sometimes stretch beneath sea level. This is what happened with another vanished continent known as GreaterAdria. Like Argoland, GreaterAdria consisted of fragments separated by narrow ocean basins, which eventually converged into a unified tectonic plate. GreaterAdria is a concealed continent beneath southern Europe. It has been reconstructed in great detail by researchers. It surfaced approximately 240 million years ago, breaking away from Gondwana, a southern supercontinent that included Africa, Antarctica, South America, Australia, and other significant landmasses. Despite its vast size, extending from the Alps to Iran, not all of GreaterAdria was above water, likely forming a series of islands or archipelagos. This could have been a potential haven for scuba diving. According to Dewey van Hinsbergen, the chair in global tectonics and paleogeography at Utrecht University in the Netherlands. For over a decade, Hinsbergen and his team gathered and examined rocks once part of this ancient continent. These GreaterAdria rocks are scattered across mountain belts in about 30 different countries. Hinsbergen said that it's very important to consolidate data from diverse geological surveys and maps so that we can get a comprehensive overview. While GreaterAdria belonged to the African tectonic plate, it was distinct from the African continent due to the intervening ocean. This gradually slid beneath the Eurasian tectonic plate in what is now southern Europe. Around 100 to 120 million years ago, GreaterAdria collided forcefully with the European landmass, initiating a process where it began to subduct beneath Europe. Subduction is when one tectonic plate is forced to move beneath another. These can cause some of the most powerful earthquakes on Earth. However, not all the rocks from GreaterAdria followed this subduction. Some, being lighter, were essentially scraped off during the collision. This scraping off mechanism is like moving your arm under a table. Your sleeve crumples as a result. In the case of tectonic plates, this results in the formation of mountain chains such as the Alps. Tectonic plates are large slabs of rock, part of Earth's outer shell, that move over the planet's mantle. The mantle is the layer of rock directly above the Earth's core. Collisions between tectonic plates can result in the formation of mountains. This is what happened with GreaterAdria. This geological process not only shaped these mountainous terrains, but also preserved these ancient rocks, making them accessible for geological study. In their research on GreaterAdria, lead author Dewey van Hinsbergen and his team delved into the orientation of tiny magnetic minerals within these rocks, formed by primitive bacteria. These magnetic particles, created by the bacteria to align with the Earth's magnetic field, were left behind in sediment as the bacteria died. Over time, this sediment solidified into rock, effectively freezing the magnetic particles in their original orientation hundreds of millions of years ago. Analysis revealed significant rotations in many of these rock regions. Furthermore, the team meticulously reconstructed the connections between large rocks that once existed side by side, such as those found in volcanic belts or extensive coral reefs. Geological activity in the form of moving faults had scattered these rocks like pieces of a broken plate. Hinsbergen compared the process to solving a vast jigsaw puzzle, spending a decade carefully reassembling the scattered pieces. Using advanced software, the researchers crafted detailed maps illustrating the ancient continent's trajectory. Their findings confirmed that GreaterAdria not only moved northward, but also experienced a slight twist before its eventual collision with Europe. Ultimately, GreaterAdria's subduction into the Earth's mantle left its upper layer intact, giving rise to the mountain ranges observed in southern Europe today. It was thanks to these mountain ranges that we were able to find out the existence of GreaterAdria. But what's intriguing is that Argoland lacks tangible evidence in the form of folded rock layers. Why Argoland is so hard to find? If continents can plunge into the mantle, disappearing without a trace on the Earth's surface, our understanding of the planet's geographical history would be limited. Reliable reconstructions of past supercontinents and Earth's geography would be nearly impossible. These reconstructions are crucial for understanding biodiversity and climate evolution, finding raw materials, and grasping how mountains form and the forces behind plate tectonics, which are two closely related phenomena. The focus turned to Southeast Asia to decipher Argoland's destiny. The team was dealing with islands of information, which made their research lengthy. 7 years were spent piecing together the puzzle. Unlike Africa and South America, where a continent nearly split in two, Southeast Asia is a different story. Argoland shattered into numerous shards, hindering a clear view of its journey. However, a breakthrough occurred when it was recognized that these fragments reached their current position simultaneously, unveiling their past connections. Like a mosaic, the broken pieces came together, concealing Argoland beneath the dense jungles spanning Indonesia and Myanmar. The unique characteristic of this microcontinent lies in its fragmented nature. Unlike a singular, well-defined continent, Argoland resembles an archipelago, comprising microcontinental fragments separated by ancient oceanic basins. It shares this trait with GreaterAdria, now mostly subdued into the Earth's mantle, and Zealandia. Zealandia is a lengthy, slender microcontinent that mostly lies beneath the South Pacific Ocean. Breaking away from Antarctica some 100 million years ago and later separating from Australia around 80 million years ago, Zealandia is about half the size of Australia, yet only 7% emerges above sea level. The primary terrestrial regions are the North Island and the South Island, constituting New Zealand, alongside Stewart Island and various smaller islets. The northern edge of Zealandia encompasses New Caledonia, a French-governed archipelago. With a predominantly mild temperate climate, Zealandia has glaciers on its major islands, including the expansive Tasman Glacier on the South Island. The microcontinent, shaped by the last glacial era, showcases fords and valleys. On the other hand, New Caledonia experiences a tropical climate similar to Oceania and the South Pacific. Zealandia has intense tectonic activity. This is because it's between both the Australian and Pacific plates. The north exhibits significant volcanic activity, featuring 6 major volcanic zones prominently in the Taupo volcanic zone on the North Island. Geothermal phenomena, a result of Australian and Pacific plate interactions, manifest as natural geysers and hot springs. Characterized by tectonic uplift, both the North Island and South Island house volcanic mountain ranges, the North Island volcanic plateau and the Southern Alps respectively. Zealandia was originally part of Gondwana around 1 billion to 542 million years ago. Meanwhile, the process of Argoland's splintering commenced approximately 300 million years ago. Advocat and Van Hinsbergen's detective work puts Argoland between the geological systems of the Himalayas and the Philippines. Their findings explain why Argoland is so fragmented, revealing that the breakup accelerated around 215 million years ago, causing the continent to shatter into thin splinters. The geologists conducted fieldwork on various islands such as Sumatra, the Andaman Islands, Borneo, Sulawesi, and Timor, verifying their models and determining the age of crucial rock strata. What's interesting about this finding is that these fragments of Argoland could have played a role in shaping the unique biodiversity observed today. These fragments collided with Southeast Asian landmasses, and in this process it could have influenced the distribution of species in this region. This unique distribution is currently referred to as the invisible barrier. Invisible barrier. This is the Wallace Line. This is an imaginary but also real boundary. This perplexing line was established by British naturalist Alfred Russel Wallace in 1863. It signifies a crucial evolutionary divide triggered by a continental collision millions of years ago. The collision led to profound climate shifts impacting species on either side differently. The Wallace Line was initially charted during Wallace's travels through the Malay archipelago over 160 years ago. The Malay archipelago is a chain of over 25,000 islands spanning Southeast Asia and Australia. The line puzzled ecologists for decades. Wallace noticed a stark transition in species beyond a certain point, which he termed the Wallace Line. Although portions of the line have been adjusted based on new findings, the puzzle persisted. On the Asian side of the line, creatures exclusively originated from Asia, while the Australian side showcased a mix of Asian and Australian lineage. The asymmetric distribution of species defied explanation for over a century. However, research in 2023 proposes that extreme climate changes shape the uneven distribution. This was a consequence of tectonic activity around 35 million years ago, when Australia separated from Antarctica and collided with Asia. This transformation gave rise to the Malay archipelago and offered a plausible explanation for why Asian species could migrate in one direction but hindered Australian species from moving the other way. In a study published on July 6, 2023 in the journal Science, scientists employed a computer model to replicate the effects of climate shifts triggered by the collision of continents, particularly focusing on how animals were influenced. The model considered the dispersal capability, ecological preferences, and evolutionary relationships of over 20,000 species on either side of the Wallace Line. The findings indicated that during this period, Asian species were more adaptable to the Malay archipelago. The primary climatic alterations weren't directly caused by the continental shift, but rather by their influence on the Earth's oceans. As Australia separated from Antarctica, it unveiled a deep ocean area around Antarctica, now known as the Antarctic Circumpolar Current, or ACC. This ocean area significantly altered the global climate by making it cooler. The ACC is the world's largest ocean current, and it remains essential in regulating Earth's climate. According to Alex Skeels, the lead author of the study and an evolutionary biologist at the Australian National University, the evolving climate affected species disparately. While Southeast Asia and the newly formed Malay archipelago maintained a warm and moist climate, Australia became colder and drier. Consequently, creatures in Asia adapted to the warmer conditions and utilized Malay islands as stepping stones towards Australia. In contrast, Australian species, having evolved in a cooler and increasingly arid climate, struggled to establish a presence on the tropical islands compared to their Asian counterparts. The researchers envisioned that their model could serve as a tool for predicting the impact of contemporary climate change on various species. Skeels expressed hope that the model may help them predict which species may be better versed at adapting to new environments as changes to Earth's climate continue to impact global biodiversity patterns. In essence, the more we piece together Argoland, the more we can learn about both our climate and our past. Let us know what you think about Argoland in the comments. Be sure to leave a like and subscribe for more.